Welcome back to Wildcat Academy, where today we're going to be learning about biconditional statements. You see these in the first part of learning about geometry. A biconditional statement is a statement created from a conditional and its converse to form an if and only if statement. And that information right there is going to be really important as we start writing biconditional statements. We typically see these from definitions. So our notation, we're going to pick up the notation from conditional statements, which P implies Q. So if you're unfamiliar with that notation, be sure to watch our other video on conditional statements. So P implies Q, and then Q also implies P. So we take these two statements and we create the statement P if and only if Q, which this means both P implies Q and Q implies P. There. So, and a little side note here is that if and only if, you'll see this represented as I and then double F, and that means if and only if. And you'll see that written several times throughout this lesson on biconditional statements. So we might see P if and only if Q. And you just have to know that the IFF, that's not a typo or a mistake, that represents if and only if. So one of the first types of problems that we encounter whenever we dig deeper into biconditional statements is to be able to write the conditional statement and converse within each biconditional. So we want to identify the two statements. We want to identify the first statement and then the second statement. And these are our P and Q statements here. The P statement, two segments are congruent. So the Q statement, two segments lengths are equal. We will combine those, you'll see those combined on either side of the if and only if statement. Now, whenever we're writing the conditional statement, we will just put if before one of the statements and then segue into the Q statement with then. So you can see our conditional, if P, here's our P statement, then Q. So if two segments are congruent, then their measures are equal. And then we can take the converse by reversing that, Q then P. And the converse is if two segments lengths are equal, then the segments are congruent. So the converse is if two segment lengths are equal, then the segments are congruent. And the conditional was P implies Q, and then we just reverse those, Q implies. All right, so here's example 2. Write the conditional statement and converse within each biconditional. Once again, we have the biconditional statement. Two angles are a linear pair, and then if and only if they are both adjacent and supplementary. All right. So once we have identified our P and Q statements, we can then just write our P implies Q and our Q implies P. So you can see that we've done that here. Our conditional statement, if two angles are a linear pair, then they are both adjacent and supplementary. Our converse statement is if two angles are both adjacent and supplementary, then the angles are a linear pair. All right, so our converse is if two angles are both adjacent and supplementary, then the angles are a linear pair. So in this problem, we are going to start with the conditional, and then we will write the converse, which once again is Q implies P, and then we will write the biconditional, P if and only if Q. And don't be confused by that notation. Sometimes we represent that as a double arrow, P if and only if Q. So if a square has a side length of 6, then it has an area of 36. So our converse is if a square has an area of 36, then it has a side length of 6. So we will see that this is the Q statement, and then we have implies the P statement. So in the biconditional, we will take a square has a side length of 6 if and only if it has an area of 36. So this is our P statement, and then we have the if and only if, or maybe the double arrow implies Q. It really doesn't matter. It's a matter of style whether or not you write the Q statement first and then the if and only if P, because it does not change the meaning of the biconditional. These two in the biconditional can be swapped if you really want to. I think typically it's pretty customary to go ahead and whatever you've identified as the first statement in the conditional, you go ahead and list that first, but it wouldn't change the meaning of the biconditional if we did switch these. All right. So example 4, determine if each biconditional is true. If false, give a counterexample. So we have a good understanding of what a biconditional is. Now we're going to start talking about it, the truth value of the biconditional. So if false, we're going to give a counterexample. A counterexample is simply an example that would prove the statement as false, or be an example of why the statement is false. An angle is a straight angle if and only if its measure is 180 degrees. So we want to identify the P statement and the Q statement here. The P statement is an angle is a straight angle, and then the Q statement is its measure is 180 degrees. We will then examine two statements. P implies Q and then Q implies P. If both of those are true, then our biconditional will be true. All right, so the conditional, if an angle is a straight angle, then its measure is 180 degrees. So we're going to evaluate that to be true. The conditional, if an angle is a straight angle, then its measure is 180 degrees. We will evaluate that to be true, because that comes because we started with the definition. That is definitely going to be true. Straight angles do have 180 degrees. And then we'll evaluate the converse. If a measure of an angle is 180 degrees, then it is a straight angle. That is also true. So because our conditional and converse both are true, because our conditional and converse are both true, then our biconditional P, if and only if Q, will therefore be true. Okay? Example 5, we're going to determine if each biconditional is true. If false, give a counterexample. Jill is a volleyball player if and only if she is an athlete. All right, Jill is a volleyball player. We're going to identify that as our P statement, and we will identify she is an athlete as our Q statement. So we're going to write both our conditional and our converse. Our conditional is if Jill is a volleyball player, then she is an athlete. Well, that has a truth value of true. The converse, if Jill is an athlete, then she is a volleyball player. Well, that one is false. And our counterexample would be Jill could be a basketball player, meaning that she's an athlete, but it doesn't necessarily lead us to the conclusion that she is a volleyball player. So in this case, P, if and only if Q, would be false because both the conditional and converse are not true. All right, so in example 6, we're going to write the definition that we're given as a biconditional statement. Definitions are where we get most of our biconditional statements. So in example 6, we have the definition of a quadrilateral. A quadrilateral is a polygon with 4 sides. So we are going to have the first part, typically the term, will be our P statement, and then we'll have a Q statement, which will be everything after the is or a verb in the sentence or the statement. So in a definition, you typically will have the term as one of your statements, either P or Q, and then the rest of the definition will be the Q statement. So we'll have P and then Q. So in our example now, all right, let's try this again completely. Starting over. All right, so in example 6, a quadrilateral is a polygon with 4 sides. And typically with a definition, you will have the term as the P statement, and then you will have the rest of the definition as the Q statement. And sometimes you have to add a few words to the P statement when writing the biconditional just for sentence structure and flow. And we'll look at that in this example. So we've added the words a figure. So a figure is a quadrilateral if and only if it is a polygon with 4 sides. So you can see our P statement and our Q statement here. We've connected those with if and only if. And once again, you can write that out if and only if or abbreviate with IFF. All right, so let's look at another example. So in example 7, we're once again writing a biconditional statement. Our biconditional statement will be true because it is coming from a definition, so we're not evaluating the truth value, but we're just going to write a statement, and this is the definition of an acute angle. An acute angle has a measure greater than 0 and less than 90 degrees. All right, so once again, we will identify the term as our P statement, and then we'll take the rest of the definition as our Q statement. So now we have P and Q identified. We can write our if and only if. An angle is acute if and only if it has a measure greater than 0 and less than 90 degrees. So you can see I have our P statement. We had to add a verb, and so an angle is acute is our first P statement, and it has a measure greater than 0 and less than 90 degrees was our Q statement, and we've connected those with if and only if. All right, so that wraps up our lesson on biconditional statements. I hope you've enjoyed. There's some videos here that you're going to see that continue the lesson on logic for high school geometry. If you found this video helpful, then please hit the like button below, and if you haven't already done so, please subscribe to the channel.